Hello viewers, today we will talk about Pythagoras theorem. Hello viewers, if I ask you a simple question, what a triangle is, what answer you will give? A triangle is a polygon with least number of sides, and a triangle is always recognized by its sides. Let us see these triangles. Here this triangle ABC has sides 9 centimeters, 10 centimeters and 13 centimeters. That is, the length of all the sides is different. So, such a triangle is called a scalene triangle. In the triangle PQR, we have side PQ equal to side PR, each is 13 centimeters and Q is 10 centimeters. That is, these two sides are equal in length. Such a triangle we call as isosceles triangle. But if all the sides of a triangle of equal length, like in this LMN, each side is 8 centimeters, such a triangle is called an equilateral triangle. So, this was one way of differentiating between the different triangles. Can we think of another way where we can say something about the triangle as to what type of triangle is this? Look at these triangles. Here in this triangle, this angle is 120 degrees, that is more than 90 degrees. So, triangle PQR is a obtuse angled triangle. But the triangle ABC has angles equal to 65 degrees, 40 degrees and 75 degrees. All the angles of this triangle are less than 90. So, such a triangle is known by the name of acute angled triangle. Now, besides this, can we think of a triangle where one angle is 90 degrees? Yes, of course, we can think of a triangle with one angle as 90 degree. So, here is a triangle L, M and N, and this angle here is 90 degrees. This triangle is called a right angled triangle, and in this one, this triangle is right angled at M. Now, these triangles have always been fascinating for the mathematicians. They had been trying to establish some or the other important aspects about the triangles. Now, one such attempt we are showing you here. In this ABC, this is right angled at B, this is right angled at B. The length of side BC is 4 units, and over BC is constructed a square which has been divided into smaller squares. They are 1, 2, 3, 4 and 4 on this side. That is, the total number of squares in this square are 16. The side AB is of length 3 units, and here again we have divided them into smaller squares, and the total number of squares in this are 9. On the side AC, we have constructed 1, 2, 3, 4, 5. 5 squares are here and 5 on this side. That makes the total as 25 squares. So, what do you find in this? That the number of squares constructed on the side AB, that is they are 9 in number, plus the number of squares constructed on the side BC, which are 16, that is equal to the number of squares constructed on the side AC, which is 25. We can verify this aspect in another way also. Here again ABC is a right triangle. On AB this square is there, and on AC we have constructed this square, and on BC the square constructed is BCDE. Now, let us put this square has been divided into 4 parts. One part is here, taking this third part, and the last one, that is fourth part, is so these 4 parts which have been taken from the square ACGH have been fixed in the square BCDE, and this part is still left blank. So, we take out this square, so what do we find? The square on this has been put over here, and the 4 parts from this square have been placed here, 1, 2, 3 and 4. So, that means the area of this square plus the area of this square is completing filling the area of square BCDE. And now, you will be interested in knowing that how did we get these 4 parts. These 4 parts are obtained first by getting the mid center of the square, which is obtained by joining the diagonals. This is that point, and then at this point we draw a line parallel to the hypotenuse, that is the side opposite to right angle. So, this line has been drawn parallel to the hypotenuse and drawing another line which is perpendicular to the hypotenuse. So, these 4 parts were obtained, and these 4 parts along with the square on this have completely fitted into the bigger square, that is the square on the hypotenuse. Now, this concept, that is the square on the hypotenuse, is equal to the sum of squares on the other 2 sides, was given by a Greek mathematician and philosopher known by the name of Pythagoras in the year 550 BC, and it is stated as Pythagoras theorem. Now, according to Pythagoras theorem, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, though the concept of right angle triangle, that is the square on hypotenuse is equal to sum of the squares on the other side, was given by Pythagoras, but it was very well known to Indians about 200 years before Pythagoras. And we can find mention of these in Bodhayan's Sulbha Sutra. Sulbha Sutra means the rule of the chord. Here, whenever any sacred ritual was to be performed, that was performed at a particular time and in a particular direction. This led to the study of astronomy, and to perform the sacred rituals, altars were prepared, that is Vedis were prepared, where yags were performed. And these Vedis were prepared according to perfect specification, and here we have one such altar with us. Now, if we happen to look at this total length G double dash G is 30 units with the midpoint, that is this is 15 units. The distance between E and F is 36 units, and distance between E and G dash is 39 units. And if we square up 39, that will be equal to the square of 39 is equal to 15 square plus 36 square. So, though the credit for this Pythagoras theorem goes to Pythagoras, but this was known to Indians much earlier than that. Now, if we have three numbers which satisfy this condition, that is the square on one number plus the square on other number is equal to the square on the third number, then these numbers are called Pythagorean triples, like 3 squared plus 4 squared is equal to 5 squared. If we take one as 5 units, that is 5 squared plus 12 squared equals 13 squares. If we take the number as 8 and the other as 15, 8 squared is 64, 15 square is 225, and 17 square we know is 289. So, that also satisfies this condition. So, these numbers are called Pythagorean triples, and any numbers which satisfy this are of the form a square plus b square equals c square. But now the question arises that do we always have to look for the square of numbers and see for this relation? To get the Pythagorean numbers, we will take two numbers a and b. After that, we will find out a squared minus b squared, 2ab, and a squared plus b squared. The numbers thus obtained will be satisfying the property of Pythagorean triples. Let us take a as 3 and b as 2. While selecting the numbers a and b, care has to be taken that a has to be greater than b. So, a square minus b square, that works out to be 5, 2ab works out to be 12, and a squared plus b squared 13. Taking a as 5 and b as 3, obviously you can see that 5 is greater than 3, a squared minus b squared works out to be 16, 2ab 30, and a squared plus b squared 34. If I take a as 10 and b as 8, then a squared minus b squared, that is 100 minus 64 will be 36. This will be 160, and a squared plus b squared shall be 164. The numbers thus obtained will all satisfy the Pythagorean triplet property. Let us take this triplet 16, 30 and 34 and examine whether they satisfy the property or not. Now, 16 squared is 256, 30 squared is 900 and 34 squared is 1156. And obviously, you find here that 16 squared plus 30 squared is equal to 34 squared. Now, let us read that Pythagoras theorem once again, that in a Pythagoras theorem, this states in a right triangle the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, let us give the proper proof for this. Now, here I have a triangle ABC which is right angled at A, and from A I will draw perpendicular onto side BC. Let us name this point as D. Now, considering the triangles A, B, C and D, B, A, we find that angle A is equal to angle D, each being 90 degrees, and angle B is equal to angle B common to both. So, therefore, triangle ABC is similar to triangle D, B and A. So, the triangles are similar, that means their corresponding sides must be proportional, that is AB upon DB, this is equal to BC upon BA. If we cross multiply this, we get AB times AB, that is AB squared is equal to BC into BD. Now, we will apply the same to the triangle ABC and ABC and in triangles A, B, C and D, A, C. We have again angle A equals angle D, each being 90 degrees. Angle C is common to both the triangles. So, angle C equals angle C, this being common, and therefore, we can say that triangle ABC is similar to triangle DAC by AA similarity. Now, since these triangles are similar, so therefore, their corresponding sides will be proportional, that is AB upon DA, this will be equal to BC upon AC is equal to AC upon DC. Taking this last equality, we find that AC square is equal to BC into DC. So, we have AB square equals BC into BD and AC square equals BC into DC. Now, adding these two equations, we get AB square plus AC square, that becomes equal to, if from these we take BC common, this is BC into BD plus DC. But BD plus DC is nothing else but BC. So, this is BC into BC, which is BC square. So, we get the result that AB square plus AC square is equal to BC square. That is, the square on the hypotenuse, this BC is the hypotenuse being the side opposite to 90 degrees, is equal to the sum of the squares on the sides AB, AB square and AC squared. So, here we had the formal proof of Pythagoras theorem. Now, let us apply this theorem to some of the problems. Now, here the first problem is a man goes 10 meters due east and then 30 meters due north. Find his distance from the starting place. Now, since in this case the directions are given upwards pointing out north and sidewards here pointing east, the man first went 10 meters due east. So, if we take this as 10 meters, he first moved a distance of 10 meters from O, and then he moved a distance of 30 meters due north. That means he went in the upward direction towards north, and that was 30 meters. Now, the man finally is at this place. So, what is the distance between these 4 points? This we have to calculate. If you look at this triangle, here this angle is 90 degrees. Name this point as A and this point as B. Opposite to 90 is hypotenuse. So, according to Pythagoras theorem, OB square equals OA square plus AB square. OA being 10, so this is 10 square plus 30 square, that makes it 100 plus 900. So, therefore, OB will be equal to square root of 1000, and that is 10 root 10 meters. So, the man who moved in this way, that is first 10 meters towards east and then 30 meters towards north, he is at a distance of 10 times root 10 meters from his starting place. So, this is how we applied Pythagoras theorem to one of the problems. We see another problem here. In this one, two poles of heights 6 meter and 11 meter stand on a plain ground. If the distance between their feet is 12 meter, find the distance between their tops. Again, to get at this its solution, we have to draw the diagram for that first. Now, here the two poles were 11 meter and 6 meter. These have been shown like this, and they are standing on the level ground. Let this pole be AB and this pole be CD. Now, the distance between their feet is 12 meters. Now, since the poles always stand vertically on the ground, so that means this angle is 90 and this angle is also 90. And we are supposed to find the distance between their tops, that is the distance between A and C. Now, to get the distance AC from A, I will draw a line perpendicular to CD and mark this point as E. So, obviously, here this distance will be equal to this. Since the total distance is 11, so this distance left over is 5 meters, and the distance AE will be equal to the distance BD, that is 12 meters. This angle is 90 and we had drawn AE perpendicular to CD, so this angle is also 90. So, taking triangle AEC, Remember here that AE is perpendicular to CD, and since BD is perpendicular to CD, so AE is parallel to BD. This distance BD being 12 meter, this is also 12 meter. So triangle AEC is right angled triangle, and what point it is right angled at? At E. This is right angled at E. So applying the Pythagoras theorem to this, we find that AC square is equal to A E square plus E C square. Since we have to calculate this AC, so that will remain AC square. AE is 12 units, this is 12 square, plus EC is 5 units, so 5 square. AC square is equal to 144 plus 25, and that is equal to 169, which implies that AC is equal to square root of 169, which is 13 meters. So here again, by simply applying the Pythagoras theorem, we could find out the distance between their tops. Another problem which we normally face is that if we have to put a rod in a room, what should be the length of the longest rod? Let us say the room is normally of cuboid shape. So here when we have to place the longest rod in a structure like that of cuboid, it will be from this point to this point. And to get this length, we will have first to find out the length of this diagonal. To get the length of the longest rod, we have to find first the distance between this point and this point. And obviously here, this being the length and this being the breadth, this will be under root L square plus B square, because this triangle is forming a right angle triangle at this point. Now the longest rod will be from here to here. Now we have found out this length, and here this is the height of this is the height, and again if we apply the Pythagoras theorem to this triangle, we can find out the length of this rod. Now let us see that in the figure also. Now in this one, here is the length and this is the breadth. First we find this diagonal, this is length of this and this is breadth. So this length right from here till here will be under root L square plus B square, because here this triangle is a right triangle. If I name this A, B, C. And where is the longest rod? The longest rod will be from A to E. And that will come out to be under root L square plus B square and plus H square. That is the length of the longest rod that can be put in a room of length L, breadth B and height H is given by under root L square plus B square and plus H square. Now we saw this property of right triangles, that the square on the hypotenuse is equal to sum of the squares on the other two sides. But if we have a triangle like this over here, this is PQ QR with PQ 8 units, QR 17 units and PR 15 units. Let us see the square of QR, that is QR square will be equal to 17 square and that is equal to 289. PQ square is 8 square which is equal to 64, 50, then PR square is equal to 15 square which is equal to 225. So what do you find? That PQ square plus PR square, that is the sum of these two, is equal to QR square. The result we get from there is that PQ square plus PR square is equal to QR square. So this is satisfying the condition of Pythagorean triples, hence this triangle must be a right triangle. Now the question arises, at what point this is right triangle? At the point, since this 17 square is equal to 8 square plus 15 square, so the angle opposite to this longer side must be a right angle. So at P this is right angled triangle. Now this is nothing else but the converse of Pythagoras theorem. So let us state the converse of Pythagoras theorem. The converse of Pythagoras states, in a triangle, if the square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. And that's all for the day, and in our next program we will be doing some problems based on Pythagoras theorem. Thank you.